Hello all CMA final students. So welcome to this another video on marathon for CMA final students for the subject strategic cost management. So the next topic is assignment. This particular topic is very important for this coming attempt, that is December 25. The reason is very simple. In the previous attempt it was not covered, and according to the psyche of the students, this particular topic is very easy for them. Of course it is a very easy topic. In this particular video, what is that new thing I am going to do is I am going to tell you the logic of this Hungarian rule, which is used as a solution technique for assignment problems. So that is the special thing I am going to do in this video, along with the concept also as usual. So let's start now. So what is assignment? Assignment, basically it is a special case in linear programming problems. So if you are already aware of linear programming, when you are going to use that linear programming technique, probably immediately will understand. So whenever there is an objective to be achieved subject to certain restrictions, so generally we use linear programming. So in linear programming only, so the similar conditions exist for even assignment also, but it is a special case because one-to-one allocation should be done. So that is the reason we are calling this as a special case in linear programming problems. So that means even this assignment can be solved using linear programming solution method, that is simplex method. Even transportation also we can use actually to solve this special case. Now what we are going to do in this particular assignment, I mean what exactly is assignment is, it is allocation or allotment of a particular resource. Resource could be a human being or a machine for a activity, for a job, for a task. This is called as assignment. That is what is written here. Assignment involves allocation of various resources to various activities, basically the receiver, on one-to-one basis with an objective to minimize cost or time. So this is the main thing here. So what is the main objective here is to minimize the cost or time. So you need to allocate in such a manner that should result in a minimum cost or minimum time. That is the main objective. So it is a minimization problem. Assignment is a minimization problem. So this is what is the meaning of assignment. Now you can see the conditions is always only one-to-one assignment you can do, and the objective should be minimization. So these are the conditions. So what are the various scenarios of assignment is, that is what listed out here. Assigning a salesman to different regions, vehicles and drivers to different routes, products to factories, jobs to missions, contracts to bidders, research problems to teams. So these are various examples of assigning things to various activities. Now what is the solution technique which we apply for assignment? What is the solution technique we are going to apply is Hungarian method. So it is named after the mathematician, I mean the country, the origin country from where he hails. So that particular country name is being used here. So Hungarian method is the solution technique for this. There are other techniques also, as I was telling you initially. Simplex also we can use, transportation, and there is another method called as complete enumeration method. So these are the other techniques available, but in assignment the shortest time will be using this Hungarian only. Now let us take one case now, special case. Now if you see in this case, let us understand now solution, how to get the solution in assignment case. So for that I am taking a special case of linear programming, or I can say problem, assignment problem. So in this you can see there are 3 jobs A, B, C, and there are 3 missions X, Y and Z, and all the figures inside this matrix cells represent cost in rupees. Now the question is, which job should be processed in which mission? Okay, so that my cost will be minimum. This is what I need to do here. So assigning the jobs to the missions, or missions to jobs, either way. So now what we will do is, forget about the technique, everything, keep it aside. Just let us see, because our objective is what now? I need to process this job in a machinery which will result in lower cost. This is my objective. Yes. So let us see whether we can do this, without applying any technique here. Directly can we do it or not? Let us check. First, job A, in which mission should be processed? See now, here the cost is least or not? So let us select this. So what if job A is processed in job Y? Of course, very good, it is least cost, we selected, great job. Next, job B, least cost here 19, very good. And what about job C? Now you are stuck. Already mission Z is assigned to job B, mission Y is assigned to job A. Now according to the condition of least cost, job C should be assigned to mission Z only. So if you do directly, we are unable to achieve the objective of minimum cost. So I need to go to what? Next 124. So but I want minimum cost. So that is the reason here I have taken a small case here to logically explain the Hungarian rule. Why there is a need for Hungarian rule? So here directly I am unable to allocate or assign in a manner that my overall cost is minimum. So here job C, we are unable to assign to a least processing cost mission, that is Z. So this is not possible. So that is the reason we are going to apply Hungarian rule. Now here what is the objective in this? What is the objective here is minimization of total time here, rather than time it is cost here, because I have given cost now. Minimization of the cost is the objective of this special case, right? Next, so now what is the objective function is? The objective function is to minimize the cost. And what are the variables here? The jobs and the missions are the variables which needs to be assigned. So here assign to which job is to be assigned to which mission. That is the variable here. And here only one job can be assigned to one mission. One job can be assigned to one mission. Right? So the objective is to minimize the cost, and the variables here is only one job must be assigned to one mission. Okay. The variables are job ABC and mission XYZ, and every job must be assigned to this mission. Now these are the conditions. Now how to get the solution? Solution is what? Now I need to assign every job to a mission in such a manner that my overall cost is minimum. This is what I need to achieve. Okay, so let us do that. Logic wise only we will do that. First, logic wise only we should do that. Before giving you the steps, now let us take these figures 25, 15, 22. There are solution for the solution with logic. Right now, there are three jobs: job ABC, and three missions XYZ. XYZ. Let's take the cost figures here: 25, 31, 35. 15, 20, 24. And here 22, 19, and third one is 17. So these are the jobs, these are the missions. Now, condition is every job must be assigned to a mission with the least cost. Okay, first let us do that. Now, going by this condition, I will job A I will allocate to this one, Y. Okay, least cost. Job B here 19, right? Next, job C here, going by the least cost only here, it is 24 what I have taken. Yes, if I directly select now, can I select 17? That is not possible, right? So that is the reason what we can do here is, what is our objective? Our objective is to minimize the cost. So here what we will do is, the first step is prepare an opportunity cost matrix. Opportunity cost matrix. What is this opportunity cost matrix? Is from every row, first row take a least one, 15. Yes, so deduct that figure from other elements of the row. 25 minus 15, 10. 15 minus 15, 0. 22 minus 15, 7. What does that indicate? Is now instead of Y, if I assign to X, instead of Y, if I assign to X, I am incurring extra 10 rupees or not? Opportunity cost this is. I am foregoing Y now. If I select X, I will forego how much? 10 rupees. Yes or no? Because extra cost. Similarly, if Y is only selected, there is the opportunity cost is 0. Now if Z is selected, what is the opportunity cost? By not selecting the least one is 7 rupees. Okay. Now what is your objective? The objective is to what? Achieve the least, select the least one. So which one is the least one now? Which one is the least one? Obviously Y is the least one or not? Yes. Similarly in B also you do the same thing. What is the least one? 19. So 31 minus 19 here. 12. this is 1, this is 0. Similarly, I am also doing it for third row. Least one is 17, 35 minus 17, it is 18. Yeah. This is 7, this is 0. Right? So, now what we have done in the first step here is, we have reduced from each row, we have selected from each row a least cost element, and that figure we have subtracted from the other elements of that row. Right? So, indicating that that is my opportunity cost by not selecting the least one. Now, this opportunity cost should be minimum for you or not, that is your objective. Okay, this we have done it from XYZ point of view. Right? Now, even column wise also, if you see now, X, if you see, mission X, which job should be performed on which. Now, if I go by this, according to this, I got, see, job A should be performed in job, that is mission Y. Okay, but if you see, mission X, job A 10 rupees, 10 rupees opportunity cost, job B 12 rupees, job C 18 rupees. So, now tell me, mission X should be used for which job now? According to mission wise, if you see, it should be used for, best use for which one? Job A, because the opportunity cost is least or not? Yes. So, whatever operation we have done for row wise, even column wise also we should do the same thing. Even column wise also we need to do the same thing, that is select least item from. Now I told you, no, 10 is the least cost or not. So in mission X, job A could have been done, and if you don't select this, if you select any other, then there will be an opportunity cost or not? Yes. So that is the reason what I can do is the same step whatever we have done row wise, I will do column wise also. So opportunity cost matrix. Now what I am doing is, even column wise also I am making sure that least cost, opportunity least cost is only selected. For that I am calculating the opportunity cost. I hope you are understanding the logic here. Row wise we have performed this with what logic? Now we know that if Y is not selected, I am going to pay extra 10 rupees here. If I select Z instead of Y, I am going to pay extra 7 rupees here. So that I would like to minimize. Same logic I am saying now. Mission X, if you see, earlier job A point of view we have seen, now X point of view you see, because we have to see from job point of view as well, because our decision variable is we have to minimize jobs cost by assigning to mission, even mission to what? Jobs. That is what you should remember. So same thing we should do it column wise also. So we know that mission X, in mission X job A must be processed to minimize the opportunity cost or not? Yes. So if I don't select that, what will happen? That matrix now I have to prepare. So 10 minus 10, 0. If I select A only, job A only, my opportunity cost is 0, 10 minus 10. But if I select B, then my opportunity cost will be 12 minus 10, 2. If I select C, then my opportunity cost will be 8. Similarly for mission Y. Mission Y, what is the best one now? Best one is A only. Best one is A only because opportunity cost is 0 or not. So there is no opportunity cost now, because perfect one is there or not, because opportunity cost is 0 here. So 0, 1, 7. Now third column, if you take again now, Z where it can be performed better, either B or C, because both have got what? 0 zeros only. So my opportunity cost is 0 only, no? So 7. If I select A, then my opportunity cost would be 7. Here it is 0, 0. Right now we made sure that the operation whatever we have done will ensure minimum cost. Now for this, if you see, now let's see whether we can directly assign now job A, B, C. Now if you see here, I perform two steps. First step is jobs point of view we have seen. Second step is missions point of view we have done. Now I am seeing whether I can do assignment directly or not. Now if you see, least cost, according to least cost condition, only B, job B can be assigned with that objective, that is 0, with least cost. If it is 0, opportunity cost is 0 only, no here. So directly which job I am able to assign is only B. What about C? What about C here? C also we can assign directly here. But what about A? There are two zeros now. So either you can select X or Y, because both will result in what? 0 opportunity cost only. Okay, yes. Either A or B, if we select, we'll have what? 0 opportunity cost. So if I, out of this, if I select A, then automatically I will cut what? Automatically I will cut, one more point I missed here, sorry. I forgot what is that is. Now already big blunder I created here, committed here. What is that is? Already this one, Z is assigned to B, no. Directly we are able to assign to B. Now C you cannot assign to Z because already B is assigned to Z. This is one problem. The other one is A also, again we have to either mission X we can assign or mission Y also we can assign. Either we can assign to X or Y, and C you cannot assign to Z only. Is there no? Yes. So now what we are going to do is, to resolve this, what we are going to do is, we will draw minimum lines covering the maximum zeros. What we will do here is, we will draw minimum number of lines to cover the maximum zeros. See, first row wise if you check here, maximum 2 zeros are there here. Even in this column also, last column, third column, 2 zeros are there. So I am striking out now. Okay. Now there are how many lines here? 2 lines. So indicating that now only 2, these 2 lines indicates that there are only 2 assignments possible here. Even in our case also, directly we got B, directly we got A, we can do either to X or Y, but C we were unable to get. C we were unable to get. If you remember here earlier, C we were unable to get, B we are able to get, A we are able to get. So generally in our steps, minimum number of lines we will draw or not? Yes. So I am using that technique here. So after first step and second step, row wise opportunity cost and column wise opportunity cost, then what I have done? I have checked whether I can do assignment directly, where my cost is, opportunity cost is 0. For B I am able to do directly, but for C already Z is assigned to B, C cannot be assigned to Z. What about A? A can be assigned to either X or Y because both having 0. So only B and A assignment is done, but C is not done. So to cover this, what we will do is, listen to this carefully. Now out of the remaining uncovered elements are there, no? Okay, what we will do is, we will try to minimize the cost out of that also. Whatever we have done earlier, same thing in uncovered elements we will try to do. We will try to create what? 0 opportunity cost. That is what we will, our objective is, again. 0 opportunity cost in the uncovered elements. So that is the reason if I want 0, now again same objective, minimization. So least element I will check in the uncovered elements. Least one I will check. What is the least one now? 1. This 1 I will subtract from this uncovered elements. I will subtract from uncovered elements and add at the intersection points. What is the intersection point here? Where two lines are intersecting, this one. At this point I will add that 1, and uncovered elements I will subtract. Remaining all will remain as it is, no change. Out of uncovered elements I will remove 1, and at intersection I am going to add that 1. Right. So what is the objective again here? Minimization of cost only. Now we are trying to create more cells with zero opportunity costs. That is our objective. So that is the reason we are selecting the least element out of the uncovered elements. So now if I remove 1, so 0, 0 will be as it is. 7 is an intersection, so there add that 1. 8 it will be. Now 2 is an uncovered element, remove that 1. 2 minus 1 is 1. 0. 0 will be as it is. 8 minus 1, 7. 7 minus 1, 6. This is 6. Okay. Now check whether you are able to make assignment directly or not. Okay. Now you can make, because there is an option. Because B can be done either to Y or Z. Both are having what? Zeros. Both are having zeros. So A can be done either to X or Y, or even B can be done either to Y or Z. So say for example, if job A is assigned to mission X, then obviously I cannot do job A in mission Y. This I have to cancel out. If I have to cancel out that or not? Yes. Next, job B also I can do either Y or Z. Say for example, now if Y is assigned to job B, then obviously job B cannot be assigned to Z. So I am cancelling that. Next, job C now assigned to job Z. So now we are able to do this. Yes. So this is the logic here of assignment, that is Hungarian rule. So Hungarian rule, what we are trying to do here is, we are trying to minimize the cost here. So minimizing the cost is the main thing which you should keep in your mind. So with opportunity matrix, what exactly is the concept behind that Hungarian steps, the steps whatever we call it as, is this is the logic. That is, we create opportunity cost matrix for jobs as well as missions. Then we try to minimize that opportunity cost. And in this process, if you are directly able to assign, well and good, you are able to achieve the solution. But to all, if all jobs are not assigned to each mission there, one-to-one should happen or not? Yes. Then we should do some improvement. That improvement is what? Obviously you need to make other elements also, some more also as opportunity cost as 0. Some more elements opportunity cost we should make 0, so that I can do what? Assignment. That is what we are doing. Now all this we have done logically. Selection we have done. So job A, X we have done. Job B, Y we have done. Job C, Z we have done. Okay. Now this, if you have to do it systematically, logic wise we have done. No, now systematically if you have to do, then what are the steps involved here? Right. So that is what I have given here. We have achieved the solution here, done, completed. Now this is how you have to solve assignment. So this is the logic behind this Hungarian rule. Now steps wise systematically if you have to do, the first thing row wise whatever we have done, no, that is selecting a least element there and then subtracting, that is called as row operation, or row minimization also you can call that as. That is the first step. Okay. So in a flow chart I have given that. In fact, even from your CMM material, we can refer to CMM material also. So what are the steps there? Hungarian method. What is the first step? This step only, these steps only I have explained explained logically now, till now. Let us see now. The following are the steps involved in the minimization of assignment problem under this method. First one is row operation. Locate the smallest cost element in each row of the given cost table. Now subtract the smallest element. See, it can be cost or it can be time also. Now subtract the smallest element from each element in that row. Okay. As a result, there shall be at least 1 0 in each row of this new table. So this will result in at least 1 0 in every row or not? Yes. Called the reduced cost table. We can also call it as opportunity cost table. Similarly, we should do it column wise also. We are able to achieve job wise. Even column wise also we should achieve the same thing, 0. In the reduced cost table obtained, this is a reduced cost table now after step number 1. Consider each column and locate the smallest element in it again. Subtract the smallest value from every entry in the column. As a consequence of this action, there would be at least 1 0 in each column of the reduced matrix. So again, even column wise also we will make sure that at least 1 0 is there or not. Yes, so this is what we should ensure. Row wise we should ensure that at least 1 0 we should ensure. Even column wise also we should ensure that at least 1 0 is there. How you can ensure this? By taking the least element and then subtracting it from remaining elements, either row wise or column wise. Now third one is called as optimality test. So what we will do is, I have drawn lines now, that is only called as optimality test. Optimality test is nothing but whether we are able to assign one job to one task or not, or even activity or not, or one mission or not. Draw the minimum number of horizontal and vertical lines. It can be horizontal or it can be vertical also. Not diagonal, that are required to cover all 0 elements. If the number of lines drawn is equal to the number of rows or columns of the given cost matrix, the solution is optimal. Then proceed to step number 6. If number of lines is less than the order of the given matrix, then go to step number 4. Even if you remember, when I was explaining here, when I have drawn the lines here, I got 2 lines only. But what is the order of the matrix? 3 by 3. That means 3 assignments we should do now here. But only 2 we are able to do it logically. So if 3 lines if you get, that means 3 assignments we can do. That is what it indicates. Right. So if I get minimum number of lines equal to exactly the order of the matrix, that means we can do 1-to-1 assignment, all, without being left, unbalanced there. Now, this is called as optimality test. So, once row operation is done, column wise operation is done, third step is you should perform optimality test. What is optimality test? Draw horizontal or vertical covering minimum number, that too covering most zeros, covering the maximum zeros. You should draw those lines in such a manner that they will cover the maximum zeros. Remember this point. They shall cover the maximum zeros. That is how you should draw the lines. And then the number of lines, whatever you have drawn, if it is equal to order of the matrix, that means you have achieved the optimum solution. Then after that you should make the assignment. That is also important thing. Then you should proceed to step number 6 they have given now. Step number 6 is, given the optimal solution, make the job assignments as indicated by 0 elements. This is done as follows. Earlier in the example, I have done assignment by squaring the cell entries or not? Yes, cutting the remaining zeros. So how you should do it? Step number 6 is exactly explaining that. So that is called as assignment, job assignment. Make the job assignments as indicated by the 0 elements. This is done as follows. Locate a row which contains only 1 0 element. Locate a row which contains only 1 0 element. Assign the job corresponding to this element to its corresponding person. Cross out the zeros, if any, in the column corresponding to the element which is indicative of the fact that particular job and person are no more available. So you should locate a row which contains only 0 element. Row wise, first you should check for any row is having only 1 0 element. Right, directly you can do assignment. Okay. Cross out the zeros, if any, in the column corresponding to that element which is indicative of that fact that particular job and person are no more available. Right. So what is the meaning of that is, see in this example earlier, job A was assigned to X. Okay. Or if you going by the rules here, you tell me now, when I am doing assignment, first what is the condition? This only I will take here. We got 0 0 7 after improving the matrix there. Even improvement of matrix also I have done there. A, B, C. Now, if I have to draw the lines, I need to check row wise which one is having only single 0. A is not having. What about after performing that is okay, improvement 1 0 7 0, this is 8, this is sorry 6. Now this is improvement matrix, that is after not meeting the condition, minimum number of lines were not equal to order of the matrix, so I improved it. That also we will learn. Again I will explain in the steps. Now this is the final one. Every row we ensure that we have minimum 1 0. Even column wise also we ensure that we have minimum 1 0. Now assignment we have to do. But how to do assignment is row wise check whether any row is having only 1 0. A is having 2, B is having 2, C is having 6, no 0. So you can do assignment here. Then cancel now, since C is assigned to mission Z, Z cannot be used for any other jobs. No, that means here we should cross it out because that is not available for other jobs. That is the meaning of that line there. Here they have given now, locate a row which contains only 1 0 element, assign the job corresponding to this element to its corresponding person, cross out the zeros if any in the column corresponding to that element. What is the column corresponding to that element? Corresponding to this element, this is the column now. So that we crossed out corresponding to that element, that column. Okay. Then repeat A for each of such row which contains only 1 0. Same thing for every row you should do it. Similarly, perform the same operation in respect of each column containing only 1 0 element, crossing out the zeros if any in the row in which the element lies. Same thing we should do column wise also. If there is no row or column with only one single 0 element, if there is not having only 1 0 element, then select a row or a column arbitrarily. Yes, you can do arbitrary selection also when if you do not have a single 0 row wise or column wise, and choose. So what you have to do is, if you have 2 zeros, so arbitrarily you can select one, you can select, other one you should cross it out. This is called as arbitrary selection, and choose one of the jobs and make the assignment. Thus in such a case alternative solution exists. So one person will select this one he will cross, other person will select this, he will cross out this or not. So that means two solutions are possible. We call that as alternative solution. So whenever we have more than 1 0 either in row or column, it indicates that we have more than one solution. That is the meaning of that. Right? So here if you see, assuming that the number of lines is equal to order of the matrix, we have gone here steps wise. But what if the number of lines is not equal to order of the matrix? What I told you, out of the uncovered elements, see our example in this. Here we are able to draw only 2 lines. Now out of the uncovered elements, we are trying to make another cell as 0. So that is the reason what we should do, least one only we should select again if we want to make it 0. 1 we can make 0, no. 1 if you select, this you remove from remaining uncovered elements and add at the intersection. What is the intersection? Wherever 2 lines are intersecting, there you should add that least cost element value, that is 1. That is the reason we got 8. So this is the improvement what we have to do, right? So these are the steps what we need to perform. So what are those steps? So now I will use this flow chart. What is the flow chart I have drawn here? You can see. First thing is prepare the assignment table. This is very, very important. First, you should have a square matrix. Number of rows must be equal to number of columns. This is the initial check what we have to do before proceeding with solution. First check what you should do is whether it is a square matrix or not, you have to check. Like a transportation, here also it should be a square matrix. That means number of rows must be equal to number of columns. Then we say that the problem is balanced. So first thing is whether the problem is balanced or not, we have to check. Problem is balanced or not means we have to check whether number of rows is equal to number of columns. Then, or if sometimes question may not contain a matrix also, then what you need to do? You need to draw a matrix. Square matrix you should draw. Then number of rows must be equal to columns. If that is not the case, then what we must do? Then what we should do is we should introduce either a dummy row or a dummy column. Dummy row or dummy column with 0 values inside the matrix. This is what we are supposed to do. So is it a balanced problem? If the answer is no, then what you are supposed to do is introduce a dummy row or a dummy column with 0 values in it. With 0 values. 0 values. So even if you do assignment also, okay, it is not of any relevance. Later on, if any assignment goes to a dummy row or a dummy column, then it is of no relevance. So make sure that first number of rows is equal to number of columns. If it is not the case, then add a dummy row or column. Okay, then if it is balanced, okay, given matrix is only balanced, then directly you can proceed to check whether the problem is maximization or minimization problem. If it is maximization, because our objective is what in assignment? To minimize either the time or to minimize the cost. So question is minimization or maximization, you have to check. Okay. If it is minimization, then you can proceed and perform row operation, column up. But if it is maximization, like profit matrix is given, profit matrix or revenue matrix is given, then obviously you have to maximize. So what we have to do is we have to convert that into an opportunity cost matrix. What we have to do is whenever it is maximization, how to convert into minimization is convert into a minimization problem by subtracting all the elements from the largest element. So what you have to do is in that matrix select the largest element. That largest you select, you remove from remaining all elements. So why you are doing like that? What is the logic behind that is we are creating an opportunity cost matrix. Right. Now if it is an opportunity cost that we would like to minimize or not? Yes. So whenever you get a maximization problem, try to convert that into a minimization problem by deducting the largest element from that matrix from remaining elements. Okay, then come back to this step again. Come back to this. Once you perform that, now it will become minimization. So if it is minimization, then you should proceed to obtain the reduced cost table. Which table we should prepare? Reduced cost means now after performing a row operation and column operation, that is called as reduced cost table. For this, subtract the minimum element in each row from all the elements of that row. Then subtract the minimum element in each column from all the elements of that column. then draw minimum number after that. Once it is done, now optimality test, this is called as optimality test. Once row operation and column wise operation is done, third step is what here? We can call it as fourth step, because first step is what? Whether it is balanced or not, we have to check. Then row operation, column operation, then optimality test. So you should draw minimum number of lines covering the maximum zeros. Draw minimum number of lines to cover all the zeros in the table. Okay. Now if those number of lines are equal to order of the matrix, does the number of lines drawn equal to the order of the matrix? If the answer is yes, then you have achieved the optimum solution. If the answer is no, then what we should do? We have done earlier in the example, no? What we have done? Subtract the smallest uncovered element from all the uncovered elements. So out of the uncovered elements, here, these are the uncovered elements. No, out of the uncovered, least one I selected, then deducted from these 2, 8, 1, 7, and then add it at the intersection. Add it to the elements that lie at the intersection of the lines. Keep the remaining elements unchanged in the revised table. Yes. Once you do that, perform that improvement, then come back and again perform this optimality test. Again draw the number of lines. If it is equal to order of the matrix, then optimum solution is achieved. Okay, so you might get unbalanced problem. So make it balanced by introducing either dummy row or column. That is one case. And one more thing is, sometimes you might get more than one zero in each row or column when you are doing assignment, optimality test. Once that is done, finally when you are doing assignment, that indicates that you have alternative solutions. Okay, right. Now let us do one question for this. And one more important point is prohibited assignment. Prohibited assignment means sometimes a particular person cannot do a particular job, so it should be prohibited. So whenever you want to prohibit that cell entry, then what you have to do is, how you can do that is by taking one large value. That large value only we can call it as infinite cost. So generally we will represent it by M. So whenever any particular job cannot be assigned to any particular mission, that is called as prohibition. We will have special cases like that. There what we should do is, we should take M there. M represents a highest cost, that is. So if you remove, say from M, if a number 2 is deducted, then you will get M only. Or if any number is added, you will get M only. Either added or deducted, you will get same number only. So that is the reason you are taking highest number. This is how you can solve whenever you have prohibited assignment. So this is another adjustment. So we have covered all the adjustments which generally comes in assignment problem, right? Now I have selected one question. Already we have solved one example. This example, initial example, this one special case I have solved here. First, this one only called as row operation. Since it is balanced here, it was balanced. No, why it is balanced? Number of rows is equal to number of columns. So that is the first step. Then row minimization we have done. We can call this as a row operation. Then column wise also we have done in this. Then we have done optimality test. Okay, optimality test is nothing but drawing the number of lines. So this is your flow chart. I am writing steps here. What are the steps? Step number 1 is initial check. Preliminary check we can call it, or initial check, where we have to see whether the problem is balanced or not. Second one is row operation, third one is column operation, fourth one is optimality test, drawing minimum number of lines. Then if minimum number of lines is equal to order of the matrix, then that means you have achieved the optimum solution. Then you should do assignment. Okay, how you should do assignment also? Make sure that first you do assignment to only every row having only 1 0. Give that priority first, whether row wise or column wise, having only 1 0 first, only that you assign. If you have more than one, then arbitrary allocation you can do. And if there is any prohibition to any job, to any mission, there you keep m value, which represents the highest value. Whether any element is deducted or added, ultimately that value will be there. That is prohibited. We will do prohibited problem also. Now one important question for December 25 first, this question we will solve. Then even other questions also we'll try to take up. Some more important questions, tough questions we'll try to take up. Now see this question. In this question, what they have given: a solicitor firm employs a typist. Legal firm, that is, solicitor firm employs typists on hourly piece rate basis for their work. There are 5 typists, and their charges and speeds are different. Their charges and speeds, their speed, typing speed, and their rate is different. According to an earlier understanding, only one job is given to one typist. This is the condition in assignment or not. One job can be given to only one typist, and the typist is paid for full hour, even if he works for a fraction of an hour. So even if he hours 15 minutes, 20 minutes, still payment is done for the full hour. Find the least cost allocation for the following data. So least cost allocation, that means I should do allocation of each typist to the job in such a manner that my overall cost is minimized. So that is what we should do. If you see, first of all, here it is not given in an matrix form. Okay, this is a past examination question, right? This type of question you don't find in your material. Now here's matrix is only not given here. So what we need to do, our objective is to minimize the cost or not. So I need to prepare a cost matrix. Which matrix I need to prepare? Cost matrix. What they have given here is typists they have given A, B, C, D, E. These are the 5 typists you have. How much they are charging? 5 rupees per hour, 6 rupees, 3 rupees, 4 rupees, 4 rupees respectively they are charging. And how many pages they can type per hour? 12 pages per hour. A can type 12 pages, B can type 14 pages, C can type 8 pages, D 10, E 11 pages. And what are the jobs also given? Jobs are P, Q, R, S, T. Job P, how many pages total? 199 pages. Job Q, 175, followed by rest of the jobs R, S, and T. Now I should prepare a cost table. How to prepare a cost table is, so what should come here? Row wise obviously typist should come, job should come on the column. See, anything you can take, jobs you can take row wise, and then column wise you can take typist also. So I am taking typist row wise. A, first I need to prepare which matrix? Cost matrix we should prepare. Cost matrix. So A, B, C, D, E. These are the 5 typists. Now jobs P, Q, R, S, T. Now, how do you get cost here? Analyze. To each typist we have to pay per hour or not. So that means we need to know how many hours they will take. First of all, what we should know? Each typist will take how many hours for the job. How to get the number of hours is job P is there. How many pages? 199 pages. So speed of typist A is 12 pages per hour. That means how many hours he will take? 199 divided by 12 pages. If you take 199 divided by 12, roughly you are getting 16.58 hours something. So even for fractional also they are going to make a full payment. They have given a full they have given in the question, typist is paid for full hour even if he works for a fraction of an hour. So he will get payment for how many hours? 17 hours. So if I give it to now P, 199 divided by 12, I am getting 17 hours after rounding off. So 17 hours into what is the per hour pay for him? 5. So 17 into 5, how much? 85. So this is how we should prepare. So how did I get for A? A is equal to 199 pages, 199 divided by 12 is equal to 17 hours at the rate 5 rupees. We are getting 85 rupees. So that is what I have written here. Now same 199 pages, if B, typist B is typing, how many pages he can type? 14 pages he can type per hour. So 199 divided by 14, rounding off 15. Any fraction at the rate, what is the rate for B? 6 rupees per hour. 90. C, 199 divided by, what is the speed? 8. 25. At the rate, what is this rate? C3. 75. D, 199 divided by speed is 10. So this is 20 at the rate 4, 80. E, 199 divided by speed is 11. 199 divided by 11. 19 at the rate 4. 72. Okay. So 85, 90, 75, 80, E is 72. Okay. Similarly now for Q also we should do. Job Q. How many pages are there? 175. So what we have to do it now? 175 divided by 12. 14.58 we are getting. So 15 we can take. 15 into 5. 75. Then so 175 divided by 14, 12.5 we are getting. So 13 we can take. 13 into 6, 78. Next 175 divided by 8. So 22 into 3, 66. Next 175 divided by D speed is 10. So 17.5 we are getting. So 18 we can take. 18 into 4, 72. Then 175 divided by 11. 15.9, so 16. 16 into 4, 64. Then 145 divided by 12. 12.08, so 13. 13 into 5, 65. 145 divided by 14, 11. 11 into 6, 66. Next, 145 divided by 8, 19 into 3, 57. Next, D. 145 divided by D speed is 10. 14.5, so 15. 15 into D rate is 4, 60. 145 divided by 11 in 14 into rate is 4, 56. Next, yes, 298, 178. So 298 divided by speed is 12, 24.8, so 25. 25 into 5, 125. Next, 298 divided by 14, 22. 22 into 6, 132. 298 divided by 8, 37.25. So 38. 38 into 3, 114. 298 divided by 10 is 29.8. So 30, that is 30 into 4, 120. 298 divided by 11. So 28. 28 into 4, 112. And finally 178. 178 divided by 12. So 15 into 5, 75. Next, 178 divided by 14, 13. 13 into 6, 78. 178 divided by 8, 23. 23 into 3, 69. 178 divided by 10. So 18, you can take 18 into 4, 72. 178 divided by 11. So 17. 17 into 4, 68. So we prepared the matrix. Right? So this is your cost matrix. So this is what first you should do. Then you perform now number of rows is equal to number of columns. Yes. So step number 1, check, initial check. What is the initial check? Number of rows is equal to number of columns. So the problem is balanced. Problem is balanced. Then step number 2 is row operation. This is the first one. Row operation, row minimization. From each row, select the least one. What is the least one here? 65. So 85 minus 65, 20. 75, 65, 10. 65, 65, 0. 125, 65, 60. 75, 65, 10. Yes. Next, second row, least one is 66. So 90 minus 66 is 24. 78 minus 66 is 12. 0. 132 minus 66 is 66 only. 78 minus 66 is 12. Third row, least 57. Yes, so 75 minus 57, 18. 66 minus 57 is 9. 0. 57. 9 minus 57, 12. D. Least one in this is 60. So 80 minus 60, 20. 72 minus 60, 12. 60 minus 60 is 0. Then 120 minus 60 is 60. 12. E. Least is 56. 72 minus 56 is 16. 16, then 8, 0. 112 minus 56 is 56 only. Then this is 12. This is row operation. The third one is column operation. Column operation. So first one, least one is in this column, least one is 16. Yes. 20 minus 16, 4. 8, 2, 4, 0. In this, least one is 8, 2, 4, 1, 4, 0. This is 0 only. In this, the least one is 56. So 4, 10, 1, 4, 0. In this, the least one 10, 0, 2, 2, 2, 2. This is column operation. After column operation, now optimality test. Optimality test. So that means we should draw the minimum number of lines. Now condition is maximum 0 should be covered, minimum lines with maximum zeros. So row wise, column wise, this one I can do it. Row wise also you can see 2 zeros are there. 1 0, 1 0, 1 0. Here you see maximum zeros are there in this third column. So 1. Then each row or column is having only 1 1. So directly you can take. So 1, 2, 3. So 1, 2, 3, 4, 5. 5 lines are there. So number of lines is equal to order of the matrix. Order of the matrix is 5 by 5 now. So number of lines is equal to See, the condition is maximum zeros we should cover. We should cover maximum zeros. See, any manner you can check. See, this is one pattern. Okay, first one is, no doubt this one is having maximum zeros. Then maximum means this row has maximum zeros. Right. Then 1, 2, oh, this one, only 1. So we are getting maximum zeros. If you take, yes, we should be little careful. I've gone with that. But if you see that condition, maximum zero should be covered or not. So third completely done. If you see, maximum zeros are there in the fourth row. So that I have taken, and literally we left with only this one. Yes, so that means how many lines are there? Number of lines is 3 only. 1, 2, 3. So number of lines not equal to order of matrix. So what we should do? Improvement matrix we should prepare. Improvement. What is the improvement is? First select the least element out of the least cost from the uncovered elements. Out of the uncovered, what is the least one? 1. 1 only, no? Yes. Subtracted from uncovered elements, added the intersections. So 4 minus 1, 3, 7, 1, 3. 0 is already covered by line, so 0. Next here, 1, 3, 0, 3, same as it is. Then we should not do anything, no, 0, 0, 0, 0. Intersection now, we should add this 1, no, so 1. Uncovered 4 minus 1, 3. 10 minus 1, 9. 1 minus 1, 0. 4 minus 1, 3. 0 as it is. 0 as it is, 2 as it is, 2, 2. Again, this is an intersection point, 2 plus 1, 3. So improvement we have done. Now check whether maximum zeros are covered or not, row wise or column wise. Maximum zeros 1. Then 4, 1, 2, 3, fifth row you have maximum 3 zeros. Then third row you have 2 zeros. Maximum zeros, no? If you take column wise, only 1, 1, 0 is there. But third row is having more zeros. 2 zeros you have now. And then last one you have 1, 0. So 1, 2, 3, 4 you have. But order of the matrix is 5 by 5. Again, number of lines is not equal to order of matrix. So what you should do again? Improvement, revised improvement, revised matrix. Again, same rule. Out of the uncovered elements, take the least one. What is the least one? 1. So deduct it from the uncovered elements. So 3 minus 1, 2. 2, 7 minus 1, 6. 1 as it is. 3 minus 1, 2. 0 as it is. Then 0, 2, 0 as it is. 2, 0 as it is. Then 0, 0, intersection of this one. So 1, 0, again intersection, 1 plus 1, 2. 3 uncovered, no, so minus 3 minus 1, 2, 9 minus 1, 8. 0 covered, uncovered 3 minus 1, 2, 0 covered. 0 covered, 2 covered. So 2 is an intersection again, 2 lines intersected, no? So 2 plus 1, 3. 2, 3 again is intersection, so 3 plus 1, 4. Now check again. Maximum zeros. So first row is having 3 zeros, 1. Last row is also having 3 zeros, 2. Then third row is also having 2 zeros, so done. Then you are left with only one option. Single zeros only. You have column wise or row wise, you have only, you are left with single zeros. So no, column number 1 2 3, column number 3, if you see, you have 2 zeros. Right. So 1 2 3 4 lines only again. Go on. Revised matrix. I hope I have not done any calculation mistake here. Okay. Now it is not even a live class also, so that you people can correct me any mistake. I mean figures wise. Uncovered now, if you see, least one is 2 only. Yeah. So 2 0 intersection 2 2 0, 6 minus 2 4 0 0 6 0, then 1 0 intersection, no, 3 0 3, then 0 0 0 0 0, finally 0 0 intersection 4 0 4. Now maximum 0, second one we are having, then more zeros, 1 2 3 4 zeros you have in third row, 2, then 2 zeros you have here also 2 only, so this is 1, here also 2 zeros. So I think we are getting this is one line, 1 2 3 4 5 6 lines we are getting. 1 2 3 4 5 only, we are supposed to get 5 lines only. I think somewhere we might have committed. Let me check here. Row wise, I hope here I have not made any mistake. This 85. Quickly we have to check this. First from here onwards we'll check remaining uncovered 1. So 3 1 7 3 1 0 3 3. So 0 Yeah, 0 2 2 2. Then 2 plus 3, correct. Here also we got number of lines 1 2 3 4 only we got. Here what is that we missed? Anything we missed? I will check this only. Maximum number of zeros, if I check how many zeros I'm able to cover here. 1 2 3 4. Okay, this 1, then you have here 1 2 3 4 zeros are there. Okay, this is done. Then maximum zeros, we have everywhere 2 2 zeros only. For last row 1 2 zeros are there. Then second row also we have 2. So maximum zeros we should cover now. How to cover maximum zeros? If I maximum 2 2, if I take this one, not possible. 2 I can take here. Yeah, 2 I am able to take here. 2. Here also I am able to take 2. Remaining is 1 1 only. 1 1. So overall 1 2 3 4 5 6 lines we are getting. 6 lines. I think we need to check cost matrix only. Probably, I mean, with some speed I have done calculation, no? So I think I need to check this. Right, let me check this. So here in the calculation part only we might have gone wrong here. Let me check the first one here. 199 first, 199 divided by 12 into, yes, rounded off into 5, that is done. Correct. 199 divided by, yes, this is also correct. Next 199 divided by, this is also correct. D is correct. Then 199 divided by 11, how many? 18.09. So 19 into 4, 76. Oh, so this is the mistake, guys. 76 is not 72. So in speed we missed that. I think this might be the reason why we got. Let me check now. 76 now. Row wise 76 means 76 minus 56 is 20. This one. This will become 20. Okay, then column wise least one is 18. So then least one will become 18, not 20, 16 there. So 18, 20 minus 18, 2. 24 minus 18, 6. 0. 20 minus 18, 2. Then 20 minus 18, 2. Then optimality test we should do for this one. So we should be very, very careful in the exam. Speed sometimes will kill us. See, how you could have avoided is by writing like this. That is the reason, very important. I wrote for one column, had I written for remaining also. Here I made a mistake. Okay, 19 fours I wrote, 19 into 4 also I wrote. Okay, 76. I missed there. Okay. Now, some time got killed here. What to do? Copy. Yes. Now, let us draw the number of lines. Maximum lines. This is 1. Then maximum zeros. Last row 2. Then 1, 2. Two, then 3, then 4. Yes. How many lines we are getting? 4 lines we are getting. Yes. Now improvement matrix. Now number of lines is not equal to order of matrix. Order of matrix. Improvement matrix, if you take, uncovered elements, least one is 1 only. So 2, 6, 0, 2, intersection we should add 3. Uncovered we should deduct 1. So 2 minus 1, 1, 3, 0, 3, 0, 0, 0, 1, 3, 9, 0, 3, 0, 0, 2, 2, 2, 3. Now let us draw the lines. Maximum zeros 4. Then 3 zeros are there here. 2. Then 2 zeros. So 1, 2, 1, 2, 3, 4. Again, number of lines is not equal to order of the matrix. So one more time we will perform. Revised matrix. Let's check here one more thing before we move to, because here when we take row wise, we have done that. This is 76 means 56, 20. 64 minus 56, yes, that is 8. 8, 0, 56, 12. So I am banking on these calculations here. I am assuming that yes, these are correct now. So this is also not equal now. One more time we will perform. Okay, after that I will check the institute suggested answer only directly without wasting further time. 2. What is the uncovered element? Least one here is 1 only. So 1, 2 minus 1, 5, 0, 1, 3. 0 2 0 2 0 0 0 1 0 2 2 8 0 2 0 0 2 3 2 4. So maximum zeros, first one 3 3, then each row wise you have single only 1 1, even column wise also you have only 1, I guess. Yes, so here 1 1. Yes, you will be left with the last row. If you let me show you again, maximum zeros you have in third row, 3 zeros you have, that I am striking one line. Then last row 2 zeros are there, third column also 2 zeros are there, anything you can take. In third column you have 3 zeros again, 2. Then first row you have 2 columns, 2 zeros here again, and last row also 2 gone. So 1 2 3 1 2 3 4 4 only you are getting again, all covered. Let me see here. So maximum zeros 3. If I take 3 1, then 2 lines, 3 zeros are there, then 2 zeros. Yes, now you are having only single zero. No, 2 zeros you have in this. So 1 2 3 4 only I am getting again. I think seriously somewhere I missed, guys. I need to check. Let me check where. Yes, students, so we have almost 3 iterations here. First time number of lines was not equal to order of the matrix. Again we prepared improvement matrix. Then again we prepared number of lines were not equal. Here also number of lines 1 2 3 4, number of lines were not equal to order. Then again we went to the last one. Here it is equal to 1 2 3 4 5 lines only we got exactly. I will show you here. So how many iterations? 1 2 3 3, 2 improvement we have done. After that you are getting, so third time you are getting, so we have to be little patience here, have patience. So now so again improvement matrix I have done. Out of the uncovered elements, least one I have taken, then deducted. So 2 minus 1 1. So I have done that. Now maximum zeros are there, first row 3 are there, third column also 3 only are there, so directly first row 3. Then even third row also has got 3. Then last row has got 2 zeros. Now remaining you have only 1 1. Then if you see 1 2 3, then this one, these zeros are covered here. So how many lines are coming? 1 2 3 4 lines are coming. Now again not equal to order of the matrix. Now remaining, if you check now, one more iteration. So 1 0, out of the remaining least one is again 1. So deduct it now out of the uncovered elements. 1 0 plus 1 intersection 2 0 4 1 0 7 1 0 0 2 0 3 0 1 0 1 1, then 3 0 3 0 4. Now let us check now. Maximum zeros are there in first row 2, third row 3 1, then first row you have 2, then 2 zeros, here also 2 zeros, then here 1 0. Done. Now here we are able to get, so how many? 1 2 3 4 5. That is the reason it has become an examination question. 5 iterations we have done. Finally we got number of lines here. All conditions are satisfied? Yes. Maximum zeros only we have taken lines now. First I've checked row wise maximum zeros. First row is 2 zeros, second row 1 0, third row 3 zeros are there. First one. Then fourth row you have 2 zeros. Column wise also if you check again, second column has 2 zeros. So maximum 2 zeros only are there. So I went with 2 zeros here. Then even this one also has got 2 zeros. This one also has got 2 zeros. So this one is 1. So 1 2 3 4 5. So number of lines is equal to order of matrix. So this is the matrix we need to consider. According to this matrix, now we will make assignment. So 1, now assignment we have to do it. 1 0 1 2 0 4 1 0 7 1 0 0 2 0 3 0 1 0 1 1 3 0 3 0 4. Now we have to do assignment here. Type is, what are the type is now? A B C D E, A B C D E, then you have jobs no, P Q R S T, P Q R S T, P Q R S T. Okay, first we should look for any row with single zero. First row you have 2 zeros, second row you have 1 0. Yes, so we can do assignment here. Then in that corresponding column you have any other, R cannot be assigned to any other, type is no. So that is the reason we will cut this. Then third row, do you have any single zero? Fourth row, yes, we have single zero, fourth row. Then we have to cut remaining in this column. So this cannot be assigned to any other. Okay. Then column wise also you can check any single zeros. Yes, last one. Column wise if you see, you have single zero. So that means T cannot be assigned, Q cannot be assigned to A now. Done. Yes, now C you have two options, E also you have two options. So you can do any arbitrary allocation. So what I am doing here is, I am selecting this. So this I have to cancel now. Q if it is given to C, then cannot be given to any other. Yes. Next. Q already given to C, no, cannot be given. So even in this we have to cancel out. Yes. This cannot be assigned no, Q to any other type is. So this also. Corresponding row wise, column wise also we have not. Because row wise that type is cannot be assigned to any other mission. Even that job cannot be assigned to any other type is. That is the reason column wise also we have to cancel. So this one I have cancelled. Now E left with only this. So this is the allocation, my dear students. So typist jobs, typist A, job T, typist B, job R, type is C, job Q, type is D, job P, job S. Now what is the cost? Let's take now 0 we have allocated now here, this one. So in this place, what is the value that we should consider? What is the value original matrix? 75. So it will be 75 rupees. If I give job T to A, it will be 75 rupees. Then job R to B, job R to B, R to B, this one, 66 rupees. 66 rupees. Q to C, Q to C, Q to C, 66. P to D, P to D we have assigned, P to D, 80. Then finally S to E, S to E we have assigned, this one. So 112. Add this now. What is the total cost? 75 plus 66 plus 66 be 80 plus 112, 399. Let me see the answer here. I gave you an answer, final answer, 399. So finally we got it. So here in this problem is iterations I got, first problem only I got iterations, 5 iterations I got, repetitions. Moreover, first when we were calculating that square matrix, one mistake also I have done. Okay, right. So that is what practice is required. Speed you have to maintain. No, that is a major thing. In exam, why students scores less marks is because of lack of practice. So if you have that practice of speed, then generally you will have less number of mistakes. So 399 we got answer. So very important question this one. So I am going to share this document so you can also practice this. I gave the solution also. Important question. Next one is coming to your institute material. Another important question is traveling salesman. Traveling salesman question is also very, very important. And next type of question is if it is unbalanced, what we are supposed to do. One case we will take. I will show you now. What if number of rows are not equal to number of columns? Unbalanced problem. See, unbalanced assignment problem. If number of rows is not equal to number of columns, you can see here. There are how many contractors? 1, 2, 3, 4, 5 contractors are there. How many roads are there? 4 roads are there. So that is the reason here what we need to do is one dummy road we need to introduce. Dummy we need to introduce here with a 0. Dummy road with 0 values. Then it will become what? Balanced. Number of rows will be equal to number of columns. Then you can perform. You can see here they have introduced this. Then after that you can perform the steps. And if you get any assignment for dummy, okay, it has got no relevance. That means you will not, that contractor will not get any work. Dummy assignments can be possible now. Yes. So this is one scenario. You can practice this. Okay. Right now, next one is, this one is an important question. Contractor question is important. Very, very important. Already I took 1 hour 40 minutes. So that is the reason I'm, due to time constraint, I'm not solving it. But you should do this. Very important. Then traveling salesman, prohibited assignment. With traveling salesman, I will explain. What if you have maximization problem, then what I told you, you need to convert into minimization by selecting the highest element in that matrix, subtracting it from remaining all. Then it will become minimization. Then you can follow the steps. Then traveling salesman. One more is this one, problems with restriction on assignment or prohibited assignment. Right, so I told you, sometimes a job cannot be given to a particular person. So that is called as prohibition. In that case, what I told you, a large value we should take. Generally, it is represented by infinity or m. You can use either infinity or m. So if any value is subtracted from m minus 2, m only. If any value is added, then m only. Remember this. So wherever that prohibition is there, there you keep this infinity or m. So in this problem, if you see, problem itself is little different. If you see here, this is also a very important problem. Put a star mark to this problem. This is preference problem. That is one question. This is also one of the important question. A company has taken on rent 3 floors, first, second, third of a multi-storied building for their city office. It has been decided to locate managers of marketing, purchase, HR, finance and corporate law in the office. So these are the functional managers. They have how many? 1, 2, 3, 4, 5. The management has earmarked in different floors 5 rooms having number 103, 201, 205, 302, 304 for the above mentioned managers. So 5 floors they have earmarked, okay, reserved for them. But no particular room has been allotted for any particular manager, and rather than they have been given option to indicate their preference of rooms, so that decision can be taken by management using some scientific method, and subsequently arrangement of sitting of the subordinates of various managers can be made. So here managers have been given the choice to select among 5. They have the choice to select any of the order of preference. Based on that only subordinates will be seating will be arranged. Managerial preferences are provided by in the table below, with first preference appearing in the top for each and every manager. So 5 managers are there. So what they have given is, they have given their preference. First which room, second preference, third preference, like that they have given. Marketing manager has given first preference 302 room. Then he has given second preference 103. 304 he has given third preference. So this is the preference, order of preference they have given for each manager here. It is evident that most of the managers have not given preference for all the available rooms. Yes, even though there are 5 rooms, only HR manager has given preference for all the 5 rooms. Remaining managers have not given for all the 5 rooms. That means what? They don't want to live in that. They don't want allocation of that particular room. That means we cannot allocate that because they don't have that preference. That is called as prohibition. So what we need to do is, here we need to keep m. The preference table, in the matrix table, whatever we prepare, there we should keep m. Because they feel that all the rooms do not have the facility they are looking for. Assuming that the preferences can be quantified by the members, find out which manager should be assigned with which room to minimize the preferential measure. So what they want to minimize here? The preferential measure. This is very, very important. What they want to minimize is, find out which manager should be assigned with which room to minimize the preferential measure. So whatever preference they have, that they would like to minimize. Company would like to what? Minimize that preference. So you need a preference matrix. What you need to do? You need to have a preference matrix. So how to prepare preference matrix is, let's say the preference for 103, 201, 205, 302, 304 as 1, 2, 3, 4, 5. Let's name these numbers 1, 2, 3, room number 1, 2, 3, 4, 5. Okay, then accordingly we can give preference. Now marketing manager has 302 has his first preference or not? So 302 means which number that is? 4th. So 4th room is the first preference for him. Like that, preference matrix we should prepare. Preference matrix we should prepare. So if you prepare here, what you should take here? Managers you should take here. Then room numbers you should take here. What are the room numbers? 103, 201, 205, 302, 304. Like this you can take. Then 103 room manager, which manager? First purchase manager. 103 does it has in his preference? Yes, it has second preference. He has second preference for purchase manager has second preference for 103. What about marketing manager? No, first one. Marketing manager has the second preference for what? 103. Then what about purchase manager? For 103 he has first of he is not preferring that, so that means prohibited. M we can keep there. HR manager 103 first preference, so 1 we can keep. So preference matrix we should prefer. So that is what you can see here. To M they have given. Why? Purchase manager has got no preference for this 103 room. HR manager has first preference 103 room only. Finance manager has fourth preference. And company secretary doesn't prefer this. Yes, so prohibited. So like this preference matrix you should prepare. Prepare this preference matrix, then you should minimize this preference. Company's objective is to minimize this preference. Apply these steps. Row minimization, column minimization. Now if, say for example, first row, what is the minimum figure here? 1. 2 minus 1, 1. M minus 1, M. It is M. M is a infinite figure, highest figure. M minus 1, M only. So this is the highest figure. Okay, so remember that. You can see here, row minimization 1, M, M, M. Okay, so it doesn't make any difference. M only, if anything is subtracted from M, you will get M. If anything is added to M, M only you are going to get. So this is one where matrix is not given. You have to prepare matrix here. Very important, this one. Okay guys, so 2 important questions I have covered here. I hope rest of the questions you can do it. One more thing is prohibited assignment also I've done. Traveling salesman, yes, this is also important question. Traveling salesman questions. So these 3 questions are very, very important. Traveling salesman means a salesman will start from one particular station, say A. He will go to B, then C, then D, then he has to come back to what? A. So that means a salesman should be allotted the reasons in such a manner that again he should come back to what? The original place where he started. So that kind of a problem this one is. Problem of a traveling salesman. This can be considered as a special case of prohibited assignment. Here a salesman has to start his sales tour from a particular city of his territory and visit all other cities within the territory in such a manner that he completes his tour at the same city from where he started. When the distance or time required to travel or cost of the travel between cities is known, then objective of the salesman is to schedule the tour in such a way that the total distance traveled or time elapsed for the travel or total cost of travel is minimized. This type of problems can be solved by the algorithm used for assignment. So this is only traveling salesman. So what is the condition is, now if you see this question, a traveling salesman has to visit 5 cities. 5 cities he has to visit. What are those? A, B, C, D, E. So now the assignment should happen in such a way that A should cover all these cities and again he has to come back to A. That is how assignment should be done. So that is the reason this question is a special one. A traveling salesman has to visit 5 cities. He wishes to start from a particular city, visit each city once and then return to his starting point. The traveling cost in rupee, in hundreds they have given here, traveling cost between any 2 cities is given in the table below. So this is traveling cost. This is, so what is our objective? Objective is to minimize. If you see here, some of the cells they have given M. Why it is C? Already is in city A. So city A to city A you cannot travel, no, not possible, no. So that is the reason prohibited. Similarly, if he is in city B, if he is starting from city B, he cannot go to city B, no, because he is already in city B, no. That is the reason this one is also prohibited. Again, if he is starting from city C, then again he cannot go to city C, no, already is there. So that is the reason it is prohibited. Similarly, D, D. So these are prohibited, not possible. So that is the reason it is represented by M. Then find the cost minimizing sequence of visit. cost minimizing sequence of visit. So that means we should minimize. So perform row operation, row wise. If you perform, see row wise, row subtraction they have done. So what is the first row minimum value? 4. M minus 4, M only you will get. 5 minus 4, 1. 8 minus 4, 4. 4 minus 4, 0. 1. So every row they have performed. Even column wise also if you perform, again lowest is 0. So 0 means same values only will get. M1, 2, 0, 0. Now if you see number of lines drawn here, how many? 1, 2, 3, 4 lines. Order of the matrix is 5. So since number of lines is not equal to order of the matrix, then you have to prepare improved matrix. Yes, out of the uncovered elements they have done. Now they have drawn the lines. How many they are getting? 1, 2, 3, 4, 5. They have got 5. Now accordingly they have done allocation here. See, first row you have 2. Second row 1, 2 zeros are there. Third row 2 zeros are there. Third row, fourth row also. Fourth row 2 zeros. Fifth row 3 zeros are there. So arbitrary allocation is there here. So first row they have selected B and they have eliminated other 0 because you cannot allocate city A to again D. Done. Then corresponding in this column also the remaining zeros will be eliminated or not? Yes. Done. Then second row again. Second row what they have done is, second row you have how many? 2 zeros you have. Third row you have only 1 0 you have. Third row. So directly you can allocate this. This allocation is done. Fourth row 2 zeros are there. This one and only 1 0 is left. Yes, this allocation is done. Then remaining you cannot allocate. So automatically you can do this. Now what is happening is, if you see allocations, A to B, then B to D, then C to E, C to, yes, you have C to, A to B is there, B to D is there, then D to C should be there here, it is not there. You have C to E, then you have D to A, so directly you have D to A. So but this is not meeting the condition. Why? A to B is there, then B to D is there, then from D only you should have next city, no, but it is not there. You have D to A again directly. This should not happen. All cities must be covered or not? Yes. So this is the special thing in this question. So what we need to do is, since this is not happening, we should go for next least cost in this. What is the thing you should do is, you can take liberty and take the next least cost. So after 0 you can take 1. 1 you can take it as a least cost here. So that is what you can see here. The requirement of traveling through all cities and finally returning to starting point A. Hence the solution is unacceptable here. So that is the reason what we have to do is, other alternative we can check. You can see here other alternative they have checked. So this is, in this we have random allocation also, no? So they have checked other random thing, random selection they have done, alternative 2. Even with this also, if you see what they are getting is A to D, D to B, and then B to A is getting. C is not covered. Again the solution above shows the traveling route. So this is also not accepted because of violation of the basic requirement of the problem, because all cities must be covered or not. Yes. Under these circumstances it is decided to try for assignment at the cells which are having next highest entry after 0. It can be mentioned that as far as practicable, assignment should be done at the cells having 0 only. So maximum you should try at 0 only. But if it is unacceptable, in this case what you can do is next highest you can try. After 0 next highest is 1. So you can do allocation for a cell having 1. Okay, especially where, now in this also you are not getting, no. So A you got D. A if you do directly D, it is not possible, no. So what you can do here is, first you comply the condition, single 0 wherever it is there. if you see first row, directly what you can do is, directly A to D you cannot go, no. What you can do is, first A to E, 1 you can select now. That is what we covered now here. Next highest you can take, because if you do that selection, no, you are not getting. So that is the reason next least you can select, go with E. Then remaining you can cut, no, these two. So like that, remaining is over now already. E, A to E is over. Then B you can do with D, they have done, you can see here. Then this one will be removed. Then third one they have selected this, so they have removed this. In fact, the first one, when you select, automatically this will get cancelled, right? So in this case, if you see what is the selection they got in this case, A to E got, then B, D, then C, B, D, A, then E, C. So everything is covered, you can see. A to E is there, E to C is there, C to B is there, B to D is there, and then D to A is there. So that complete circle happened here in this case by taking 1 as selection here. So this is what you should do. Okay, this is a special point in this traveling salesman question, because that condition has to be satisfied there. Next list you can select here. That is what has been done here. Okay, so these are very, very important questions, whatever we have done. I hope this video gives you enough knowledge on this assignment, and practice these questions. Whatever questions I've done, tough questions these are, practice them. So thank you everyone. And most of the students are not liking the video. Please like the video and share to most of the students, so that it will be beneficial to them also. And please subscribe also. Thank you.